research. For example, there are a lot of travel and tourism companies that are growing because of this social media influences, and they are making some good business out of it. And along with that, urban planning is a very core concept. Lot of new cities are evolving, and lot of old cities need a reconstruction. So for these, both tourism and urban planning have been kept in our mind for a long time, and more or less, this is one of the social part of the geospatial analysis, where how these urban planners actually work, because majority of the urban planners comes from the architecture and they do the M plans, and there are a lot of good institutes like School of Planning and Architectures in Delhi, in Bhopal, and a lot of our friends are actually have studied there from these particular institutes, prestigious institutes rather, and they are now doing jobs as an urban planners. So by talking to them, we also got some overview that what are the problems that they are facing and how these problems can be solved. And two of our most distinguished person in this particular field, and fortunately they are from my lab, and basically they are talking about this particular tourism as well as urban planning. So before starting this particular sessions of this webinar, the main motto of this webinar is number one, to showcase you that how artificial intelligence has changed the concepts of both tourism and urban planning. Because in tourism, majority of the work are like social related, but now that social work can be done using the artificial intelligence. And same for the urban planning. Urban planning is no more confined to the only NDVIs and its indices, and as well as only spatio-temporal changes. Urban planning has evolved a lot, and how artificial intelligence can be inculcated in urban planning. Because if you think urban planning, I know that majority of the people from the research perspective of view, they thinks about that it is the spatio-temporal change and how a particular city is changing through time. But the real applications of urban planning in nowadays is that how we can use this artificial intelligence and how we can actually give knowledge to the what we call that. For example, there are lands. So in terms of real estate, I forgot the term. It is in terms of real estate, how this artificial intelligence can be clubbed with the urban planning, and how it can determine the role in terms of real estate businesses, how the pricings are fixed. So all those things also plays a very important role. So 2 to 3 important things that you just keep in mind, that first of all, this particular webinar teaches you a broad dimensions, that how you can think differently from the other and how you can apply artificial intelligence into it. We are no longer going into debates that whether traditional methods are good or applications of artificial intelligence will make things better or not, because we all know that in each and every field, AI is there. So it is no longer a debate now. And for the last 2-3 webinars, if you have been presented here, you can easily understand that we have showed that how the traditional and like analytical hierarchical process, any other traditional approaches has been suppressed by the machine learning and artificial intelligence. So based on that, this particular webinar will teach you a lot more things, and I will tell you to wait for the end. We are showing 2 of the most bonus things in the end of this webinar that not a single free webinar will ever teach you. We have built 2 different types of product. One of the product is actually helpful for those who are actually working in the terms of urban planning along with the natural hazards. For example, urban flooding. For example, earthquake resilience. So how you can integrate this urban planning with the disaster resilience. So this is a one major thing. We have built one simulation we will show you at the end of this particular webinar, and along with it we have also made one AI based product that will provide you daily data. So how you can observe that data, everything, and we have kept it free for all of you, so that you can go, you can download the data, you can use that particular data in your near future. So stay till the end, and we will show you what we have built that majority of the Geo AIs that never thought to build of it. Okay, so we will not waste a lot of time, and I don't know how many people have actually joined. Let me see first, and then I will tell RevoMap Solutions to actually introduce 2 of our distinguished speakers. One is Arup Vaidya and Nilanjan, and then we will actually dive into this particular webinar. So just give me 1 minute. Okay, so around 74-75 people have already joined. It's great. And now I am giving dice to RevoMap Solutions to facilitate these our speakers. Okay, So thank you for listening to me. And Revo ma'am, please take the dice and please facilitate our speakers.
Yeah, thank you, Santan sir. And am I audible? Okay,
Yes,
fine,
sir.
fine, fine.
Yes, you are audible.
Okay, fine. So, dear folks, good evening, everyone. And on behalf of Rhythm of Solutions and our collaborators, Darsini Group of Solutions, I warmly welcome you all to today's session. After getting overwhelmed response of more than 300 participants in last three webinars, we conduct fourth sessions of our Geo AI webinar series, where we aim to bridge traditional geographical research with modern approaches like machine learning, deep learning, and Geo AI based automation. Today's topic, entitled as that applications of machine learning, deep learning in tourism and urban planning. It highlights how these technologies are transforming real world sectors through data driven decision making. So ReboMap Solution is a geospatial organization focused on delivering end-to-end geospatial solutions and practical training in GIS, remote sensing, and Geo AI. Darsini Group of Solution is our valued partner, actively supporting innovation, skill development, and industry academia collaboration. We are honored to have two excellent speakers with us today, Mr. Arup Vaidya, assistant professor with strong expertise in machine learning, deep learning applications, and Mr. Nilanjan Bal, UGC SRF from Delhi School of Economics, actively working in advanced Geo AI research. So this session is especially important because it is not just a standalone webinar. Today we will try to revealing the complete code structure, learning objectives, and workflow of our upcoming flagship GeoAI course, a fully hands-on program designed to take you from basic GIS to advanced machine learning and deep learning-based geospatial prediction modeling. So this course follows a complete research-oriented pipeline, starting from building a geospatial database, moving into Python-based processing, and applying machine learning and deep learning models for real-world prediction and mapping. The Geo AI is to ensure that participants can prepare real data sets and generate scientifically valid prediction output just like real research workflow. Another important aspect of this program is credibility of the certifications. So ReboMap Solutions is ISO registered, ensuring a standardized and quality assured training process. Secondly, MSME Udyam registered enterprise under Government of India, recognized as a formal educational support service provider. And last but not the least, a legally established partnership firm with proper registrations and trade licensings operating under a structured and compliant framework. So this means that the certifications you received is not just a participation document, it reflects structured training, verified standards, and institutional authenticity. You just remember this term, institutional authenticity, which adds a real value to your academic and professional profile. We are confident that today's sessions will be highly insightful and will give you a clear directions into the future of GeoAI and geospatial careers. Thank you to listening me. And now the space is for the Darsini group. Now you can continue.
Hello, am I audible and visible?
Yes, sir.
Yes, sir. Yes, sir.
Okay. A very warm welcome to everyone, and in this auspicious occasion of Akshay Titiya, hope you are very well. So today I will discuss some very interesting topic with you. And first of all, I give thanks to the RevoMap Solution and the Cine Group of Solution for inviting me. So before start the session, I just present my screen. Okay. Mhm. Is my screen is visible? So, so I give some introduction about today's topic. That I will discuss you some aspect of tourism and use of AI in tourism and site suitability analysis, and that will um, help in your research in other field also. Okay. So before starting the session, I say something that I presently a assistant professor, but I also a researcher also. Okay. So I feel the problem and situation of student and researcher what they feel, because GeoAI is a very new and emerging theme. So when in our research in PhD in four-year PhD research, we felt several problem and struggle. After that, we got this situation. So we'll tell you how to overcome this problem, and you can use this model in your research. So we share our journey, and so that will help to smoothen your research journey. Okay. So our topic is based on a real world example, and that also published in a research. Okay. So we don't tell any abstract thing. What we did, that we tell that you can also did this type of works. So our work is also published in a reputed journal, Discover Artificial Intelligence, and title of this work is Application of Deep Learning, Machine Learning, and Multi-Criteria Decision Analysis for Ecotourism Potentiality Assessment, a case study of Sundarban Biosphere Reserve, India. So in this research, we use first time deep learning in tourism studies. Before that, no studies use deep learning. In traditional studies, mainly use multi-criteria decision analysis and other traditional approach. And one study maybe in the China, they use machine learning first time, and we use deep learning for the first time. So this is our novelty, and we want to share our expertise within over you, so that you all of the student also learn this and use this in your future research. Okay. So to give some overview, that tourism presently a very interesting topic, because tourism gives one of the largest tertiary sector, and this sustain more than 200 million jobs globally. So this is a opportunity for research and for development of any nation or any place. So but before going to development, so we need to assess the area by site suitability analysis or environmental consciousness. So that will help to sustainably develop the tourism, and also improve the local condition. So for this purpose, we use artificial intelligence to identify the site, most suitable site for ecotourism also. And this method you can use in other tourism research also, so that you can develop any tourism site or other any site suitability analysis. You can also use these methodologies. Okay. So we discuss the evolution, how we come across from traditional to modern machine learning or deep learning approach. You can see that in early, we can use GIS, AHP, or multi-criteria decision analysis. Most of the studies going from multi-criteria decision analysis, fuzzy, SWOT, weightage overlay analysis, but very few, only one research come in machine learning. So in traditional, more than research are based on traditional approach. So this is an emerging trend that you will use the machine learning approach in your study. This is the you can convert change that in ecotourism studies, what type of research is previously done, like use cluster analysis, analytical hierarchical process, fuzzy logic, but machine learning has very few. So this is an emerging topic, and how this machine learning approach evolve, and what is the limitation of the earlier studies. In traditionally, we use AHP or GIS, and most India, Pakistan, Oman, this southern hemisphere country are mostly use this type of method, but there is a limitation of this traditional because they are highly subjective and linear and prone to inconsistency, struggle with complex non-linear relationship. Like in HP, we give weightage, and weightage given by the any researcher or other person, and human personal bias that can affect your result. So HP have this biasness problem. To overcome this problem, next we go to the like fuzzy logic, but TOFSIS, but they are this method also some limitation. Like this is a fundamentally human judgment based, so this method also some biasness. So, and this is the more in recent time we use machine learning. This is the most accurately method that remove this biasness and eliminate the expert bias. So we should use these recent technologies so that we can remove our biasness and improve accuracy of our study. So my study area was Sundarban. Maybe all of you know that Sundarban is the UNESCO World Heritage Site, and this is also a Ramsar and tiger conservation site. So this is the hub for ecotourism. So, but in present time, tourism is not environment friendly. So we want to propose that how can we develop ecotourism in that area so that also improve the local condition, improve the well-being of the local people, and going to sustainable development. Okay. So for that reason, we choose Sundarban, and we identify the most suitable site for ecotourism. Okay. And this is how we a traditional and advanced method. Like in our study, we not only use this machine learning, deep learning, but we also compare it with in traditional methods so that we can differentiate how this traditional method and modern machine learning, deep learning method, their result differentiate. So in our study, we compare both methods so that we can find the limitation and advantages also. So this is the methodological framework. This is the most crucial, that in our study, we divide the whole study in the 5 steps. Like in the first step, we generate the database generation. This is the basic steps of any research. And in future, we also discuss our course. In that, we will discuss how to generate this type of map also. So for this reason, we choose 16 criteria. Okay, 16 database. Based on this, we process our model. And then second step is model generation. And we use AHP, XGBoost, this is a machine learning method, and DLNN, this is the deep learning method. So we use 3 methods. One is traditional AHP, one is machine learning, and one is deep learning. So we use 3 type of advanced and traditional methods so that we can compare the result. Okay. In the next step, we will discuss further. And then we generate the potentiality map. And we also validate our map, that how this model is accurately. We validate statistically and also field verified. We don't only just verify statistically, but we go to the field and find that how our model is accurately related with the ground. for this we done the ground validation. So this is the main steps of any research. So we go to the next. So in machine learning, to any study, we need to create a inventory map. This is the basis for any machine learning data. Inventory is the previously map or previously data that is used to train the our model. How accurately we collect or create this inventory map, based on this, our result will be generated. Like what is inventory? Like if I give an example that we use smartphone, everyone. In smartphone, many smartphone have the face recognition or fingerprint recognition. When we give the fingerprint recognition, first time we train our phone that we give our fingerprint, and our mobile can recall this fingerprint, and in the next time when we give our fingerprint, mobile automatically unlock. So the first time fingerprint is the inventory. Okay, this type of. So in machine learning approach, so we have to give inventory, like what is the traditional or existing ecotourism site, that is the inventory or existing our criteria. So based on this, we can predict the future ecotourism site. So for this, we choose several source to generate the inventory map. This is the basics. So in our future course, we will teach you how to generate this inventory map, because without inventory map properly generated, we cannot find our suitable result. So this is the most crucial part of any machine learning approach. So for this, we use existing studies and also Google Earth Pro or our field verification. Among those, we generate our inventory, and we trained our model in 70% training data and 30% testing data. Based on this, we generate this type of inventory map. And this has the binary classification. One is like ecotourism site, one is non-ecotourism site. Based on this binary classification, we can generate or predict our future map. Okay, so this is the most crucial part of machine learning approach. So for generating the prediction, we choose 16 criteria, and our criteria is divided into 4 parts, like physical criteria like elevation, slope, rainfall, NDVI, and this we should develop this criteria also, and like socioeconomic LULC population. This is the all 16 criteria, and we choose 10 into 10 meter spatial grid reference system, and all criteria are in this same reference system to generate the future map. Okay, and when we choose the criteria, we also done the multi-collinearity analysis. This is the most crucial for when you can generate your analysis, but when you want to publish your research, that is the reviewer want to know how you choose this criteria. Your criteria may be wrong, may be biased. So how your criteria is judged or your criteria is suitable, that can be identify the within multi-collinearity analysis. Is our criteria is suitable for the study or not? Because same criteria is not suitable for different study area. So based on the study area, we choose which criteria is suitable for my study area. So we choose this multi-collinearity analysis to identify that our criteria is suitable or not. And in multi-collinearity analysis, we calculate the VIF and tolerance. We know that VIF is less than 5 is suitable. So all of my criteria, this is the threshold point, and all of our criteria is below 5. So based on this, we can find that this criteria is suitable for the studies. Is this criteria result is more than 5, then this criteria may be not suitable. So in our so this is the most suitable part. You want to learn this. In our future course, we also teach you how to generate this multi-collinearity analysis also. Okay. And this is our variable. We choose 16 variable, and all criteria we are generated in ArcGIS. Also, we also teach you how to generate this. This is the criteria map we generated, and this is the architecture of our tree model. Okay, this is the main methodology behind this prediction, and this is the traditional AHP method, where we choose this multi-criteria decision analysis based on pairwise completion method. But this method have some limitation, like cannot capture the complex non-linear relationship. Like we choose 16 criteria, but what is the relation between these 16 criteria? This internal relation cannot capture this AHP. So for overcome this limitation, we need to use XGBoost, and this is the machine learning based, and DLNN, like deep learning neural network. These two methods, where we also find this non-linear relationship, and that's also give remove biasness. So this is the internal structure. In our future course also, we discuss very detailed the theoretical and practical methodology of how to generate this type of model. Okay, so among those, DLNN is the most advanced, because this is the highest capacity to learn complex dynamic spatial dependencies without human interaction. Okay, so this is the most advanced method. Based on this method, we find our final result or prediction. Okay, this is our final result of three model. This is HP, XGBoost, DLNN. You can in this, where red color define the very high suitable, and green color show the least suitable. And you can, when you differentiate these three model result, that in AHP the result is very generalized. Thus most of the part is red, okay, because this is suitable, and some part are green, so this is unsuitable. So this give a generalized overview, but you cannot find the details of which this is not suitable for any planning. So to do the planning process, so we need to very detailed analysis. For this machine learning, we find us exactly which area is
sir, may
most.
I interrupt you please for one time?
Okay.
Can you please hide the meeting sharing screen that is mentioned at the bottom of your screen?
Okay.
Thank you, sir.
Okay. Thank you. So in this machine learning and deep learning method, you find that very precise result. We find that is some red spot are very high suitable, and most of the areas least suitable. So you can differentiate this result. This machine learning and deep learning result is far more better than AHP. So you can visibly compare this result. In the future, we can statistically compute the how these are differentiated. Okay. In the in AHP, approx 43% area is high suitable. Okay, and in the XGBoost, only 4.63% is highly suitable, and in the DLNN, only 6.21% area is suitable. So how precisely this machine learning and deep learning model identify the suitable zone? So this is very useful for any planning or development purpose. Okay, so this is the differentiate between two model result. After that, we can statistically validate our model also, that how this model accuracy, like we generate the ROC AUC curve, and you find that AHP has the AUC value of 0.783%, and approx 78% is correct, but in DLNN have the more than 0.91, but more than 90% is accurate. This is the three model accuracy. So machine learning and deep learning is the far more better in model accuracy also. So after that, we don't only give the model accuracy, but we also go to the field verification for identify how our model is validated with the field. because model accuracy may be 90%, but if we go to the field and find that field is different from the model, so there maybe lack. When you go to the field and collect more than 200 data and find that our deep learning model is most accurate with the ground truth also, so that validate our model result. We go to the several part of the Sundarban and find the also capture their picture also with latitude longitude also, and find that DLNN accuracy approx 87%. In field level accuracy at 87, where HP is 64%. So DLNN or machine learning or deep learning is far more better ground truth accuracy also. Okay, so and this is one of the result, that this is the one Pakhidarlai village. This is the ecotourism spot. We zoom that area, and like in this is the HP output. When we zoom the area, we find the result that HP give the very general result, but XGBoost and DLNN give more accurately result. You can, when I zoom our map, you can find that this is the three different same place. This same place is how HP and XGBoost and DLNN accurately identify the area. This red part is most suitable and green part is unsuitable. So this is the result differentiate when we ground generalize in very ground truth also. Okay, this is another part. This is a town area in Canning Town, where like HP assign that this is the very high potential zone, but XGBoost and DLNN find that this is the low suitable zone. So this is the accuracy assessment also, that HP also failed to identify the zone also. Okay, this is the result of three model. Like HP give that 43.85% area is very high suitable, but DLNN identify that 6.22% area is very high suitable for ecotourism potentiality. So this is the differentiate of three model results. So you can imagine that how model accuracy give you the real world accuracy. So this is when choose any model, this is very crucial to identify which model you use, because after using your model, that will give the result also. So this is the variability of three results. So we need to shift from HP or traditional method to DLNN to identify the most suitable area. Okay, and we also choose some feature importance or SAP diagram also, because we don't only identify the suitable zone, but behind that which criteria is affect the suitability, because which criteria give the more weightage to make the suitability zone. We find that in SAP diagram also, that distance from tourism spot or distance to mangrove or distance to river, this criteria, this is the most, we rank this criteria, this is the high, this criteria give this highest importance, and below is the lowest importance, like elevation. Okay, so above criteria is the most affect our result. So we don't only give the result, but we also find the internal cause which criteria give this more result. So like distance to tourist spot, mangrove or river, this is the most important criteria to give our result. So this type of diagram you also generate. We also teach you how to generate this type of diagram, because when you give to publish your paper, the reviewer asks to this type of diagram also to validate your model. Okay, so to go your future journey, so you need to convert your traditional HP or traditional method to modern machine learning or deep learning method, because this is the future. If you don't learn this method, you in near future your paper may not be published, or your research may be questionable. How this method? So you need to learn this recent technology to identify your future research. Okay. So I just give you a overview that how we done our work. We done our work in Anaconda. Okay, Anaconda means Jupyter Lab. So this is a cloud-based software. So you don't need any hardcore laptop condition because this is cloud-based. You can develop your model in any laptop because so when we open this Jupyter Lab, I gives one hands-on above this result. Like this is the interface of Jupyter Lab. Okay. So I give 1 minute hands-on how I generate this accuracy assessment or model. So like we have this code, like we have XGBoost. Okay, we can provide the code how to generate this type of code because AI is coming. So the code writing is not problem because we don't need to learn how to write the code. We will teach you how to generate the code. Only we can learn the process, how to generate or how to choose which type of method. Like when we give the code and we give the run, then we run this code and we will generate this type of result. Like ROC, AOC curve automatically generate above this code. Okay, and confusion matrix also, feature importance, and this shape diagram. In one code, single code, you can find all of your result. In this code, we generate this type of code because in previously we use lots of code for this type of result, but we generate a simple code that in a single code you can generate the all result in a single code. Okay, and this is the prediction also. Like okay. Okay, we can click on another code. This is the deep learning code. When we use this type of code, you can find this type of result like ROC curve, confusion matrix, feature importance, and distance shape diagram. All are in all validation also, and also prediction. This is the prediction result. Okay, we can predict, and when this result we can visualize in ArcGIS, you can find this type of map. Okay, after give you can find this type of map. So this is not very complex features, but if you don't know, this may be too much complex, but if you know the basics of this type of method, you can definitely go for it. Okay, so we face several type of problem because we in our time we don't have any course like this type of. We learn by ourselves by collaborating any foreign teacher, but you are lucky that this type of course is already in the market, so you can join with us so that you can learn this type of method so that you can use in your future study. Okay, so so this is the future of our research, GeoAI. So I can conclude myself that you can contact with me if you want to know any other things, and if you have any question, you can feel free to ask me, or you can contact with me or email me for future query. Okay, I give thanks to everyone for listening me, and give also thanks to the our organization. Okay, thank you everyone.
Okay, so dear participants, one more announcement. If you have any query, you just put it in chat box. After some time, we will discuss it.
Hello, am I audible?
Yes, yes.
Yes. Okay, that's a nice talk. Okay, so we are all, I think you all have enjoyed that how Mr. Arup Boido, who is now an assistant professor, has learned so much thing on his own and has done this entire work, that how this entire system can be built, but it takes a lot of time. It is not a one-day work. It has taken around 6 to 8 months to actually make this for the paper. But thing is that we are not stopping here. In our near future, we will be building some end-to-end product where we will not only creating the models, we will be shipping it, and we will be actually sending to the ground and the real estate that how these particular tourism zones can be used by the real estates so that they can build their own projects. So in this way, artificial intelligence is working in the industries. So we are not only building one machine learning project, we are making an entire set of end-to-end MLOps. So you have to understand that how these MLOps are made. So for that, you need to learn a lot of things. So this particular webinar is an eye-opener for you all. So now before moving to the next topic, I just want you to please listen to the next topic that is a part of Nilanjan. He is one of the finest of our AI engineers in this particular field of urban planning. And I think Nilanjan is here. So Nilanjan, are you here, present here?
Yes, I'm present.
Okay.
So
Just wait for 1 minute. I got one beautiful observation from Srivantu Raha. Srinvantu Raha. Please apply partial dependence plot also simultaneously with the shape. That will enhance your result. Okay, we will see about this because this paper has already been published, so we can't do it here. But thanks for your suggestions. We will see on it that how this is actually helping. Because see, one more thing is that we don't want too much jargon. If I find that this particular partial dependent, because we have used a lot of partial dependency curves before also, Nilanjan uses a lot. So if we see that it is giving better results than SHAP, then we will use any one of it. We will not put everything together. We will not make a hodgepodge out of it. So thanks for this particular observations. I will keep this in mind, Srinvantu Raha. And now I want Nilanjan to please show your expertise so that we can actually have some good visualization and in-depth understanding of the urban planning. So, and wait for the end because we told you that we have lots of surprises, and please don't go anywhere. And Nilanjan, without wasting a single moment, I want you to please start. Okay?
yeah, thank you, Shantan, for having me, and I also thank RevoMap Solutions for arranging such a beautiful webinar just ahead of our starting of our course. So it is actually our fourth webinar. So in this webinar, we are dealing with two things. The first one is the tourism part, and the second one is the urban planning part. The first part, tourism part, have beautifully covered by Arupda. He shows everything from scratch to publishable mode products to all of you. So now I want to hear from you guys. Can anybody tell me about what type of research they do in urban sector or any kind of thing? Just share your experience with me. Any one of you. Just 2 minutes. Please, this is our icebreaker session. Please share your experience with me. Sorry, with us. Anyone? Anyone? Okay, no. So let's begin our session for urban planning. I'm just off my camera to partake the clear visibility of my slides and all. Is my screen is visible? One Charu Sharma is here. Okay, just beginning of that. Hello, Charu. Can you please unmute yourself and tell about what your experience regarding what you have researched in that field? Please unmute yourself. Hello. Hello, Charu. Please unmute yourself for 1 and 2 minutes. Share your experience and all. Okay. So Charu Sharma written that I have done research related to LST and green cover and outdoor urban thermal comfort. So can you please elaborate what you have researched over there and what your outcome or what is your motive to deal with that research? Please be fast. No answer. Okay, let's move on to our slide. So today we will dealing with for the urban planning part, that is the from computation to automation, that is the integration of geo AI, probabilistic simulation, and digital twin modeling for urban retrospective planning. So our focus area is the Eastern Dedicated Freight Corridor. So it is a broad gauge freight corridor. So it is a broad gauge freight corridor uh, created by the Dedicated Freight Corridor Corporation of India. It is a PSU-based unit of Ministry of Railways. It is a 1839 kilometer of distance railway network where freights from different passenger traffics having a speed of 100 kilometer per hour. So it is located within from Ludhiana, Punjab's Ludhiana to West Bengal's Danpuni. So here our target is specifically the phase 2 part, that is the Pandit Deendayal Upadhyay Nagar to Bhavpur region. So Pandit Deendayal Upadhyay is actually primarily known as the Mughal Sarai region. If anyone know about the Mughal Sarai region, it is actually a city basically grown on the basis of the railway connection and all. So this is our target region, that is the Pandit Deendayal Upadhyay Nagar master plan region. What is the problem over there? So due to this EDFC development, 100 of villages intersected across multiple distinctive geometries in the Uttar Pradesh. So there is a clear growth pole based situation happening over that region. So it requires a special modeling framework to capture the continuous linear shock waves. So what type of shock waves are there? So there are two types of shock waves have been identified over the detailed research. That is, the first thing is the resettlement action plan, where the targeted peoples are the eligible for land and structural compensation and the redevelopmental part, non-till title holder, that is the structural compensation and livelihood support, who will receive that, and the vulnerable groups like the marginal farmers, women-headed households, SC/ST required weighted priority support. So all the main problem is that the resettlement action plan is that the tillage or the settlement where people are actually live, either the region will be redeveloped or they will be shipped to another place. So this is the main problem over there. And the next problem is that the land ecological potentiality, like what type of ecological potentiality is degraded due to this type of development. As you all know that when this type of mega projects are happening over our over anywhere of the world, there are ancillary things are also coming, like the NH development, national highway development, state highway development, secondary road network development and all. So we also have to take in these factors in our analysis part. So the first thing is that vegetation and soil loss, that is the reduction of NDVI, loss of soil organic carbon, hydrological basis, that is altered drainage leading to fragmented moisture availability. Next is the fragmentation of the natural landscape, like the different types of vegetations, agricultural fields and all. So it actually creates an ecological imbalance over there. So there are two problems we have been found. The one thing is that the resettlement issue, the issue related to the plots of people, and the second thing is that the ecological degradation. So what we will do, so at first we will build our geospatial data assembly line, starting from vectorization, data cleaning and interpolation, distribution checking, normalization and standardization, XY determination, and train test split. Before going to that part, I'm just give you a wide range of things that what stage we will dealing our analysis. So first stage is that the physical reality stage, the EDFC phase 2 and the RAP mandates, which I have just discussed over here. The next part is the Stage 2, geospatial assembly. We will build our data and for the analysis part. The stage 3 is that the computational engines. The computational engines are divided into 3 parts. That is module 1, DenseNet LSTM. It is a deep learning based network. CART-NN. CART-NN is a hybrid type of algorithm, and HDCA, it is a simulation network. And the 4th stage is the automation and rendering using the VCGA, that is the virtual computer graphics architecture and mass modeling. And the stage 5 is the policy reality to apply it in a policy scenario. So this is the geospatial data assembly line. This is a stage 2 part. We are moving ahead. So these are the main assembly line part in this context. So let's do it in Google Colab in a module 0. I will show you that things. So my is my screen is visible? Is my screen is visible?
Yes, sir.
Okay. So this is actually what I'm telling about the module 0, that is the data upload and preparation. So we have to install specific data, specific libraries, like I have installed as Pandas, NumPy, Scikit-learn, and OpenAccess. So these are the libraries you have to install, and based on that, you have to do your next parts. So next thing is that we have uploaded our data. Oh, so first thing first, I have run all my coded in the just before of this webinar to minimize the time coefficient. As you know, it is a 2-hour long course, and it is a 2-hour long webinar, and we are not able to show you the large thing, because you can see there is a lot of data sets are there. So in that sense, I encourage all of you to please join our main course. We will build it together from scratch. To every penny your every penny will not be in vain, I guarantee you. So the next part is that the upload of data. We have uploaded our data in the vector format. So there are different types of data I have been used here. That is LAI, means the landscape expansion index, fragmentation index, biomass, forest loss. Next, the rain use efficiency, state, performance, trajectory. The creation of these data sets are also a tricky thing. We will also share with you in the main course part, because this will take at least 1 or 2 months to create these types of data, long data. Next, RUE means the rain use efficiency, water use efficiency, and it is the settlement morphological zone, and the LD, it is our target. So next part is the data cleaning part. So we have segregated our data X and Y. Okay, so after of this, we will deal with that none part. That is there are some sorts of infinite values are there, and blank values are there. We have to fill it by using different types of interpolation techniques, or either we have to delete that part. So it is up to your expertise and what you will doing in your research. So it is basically a non value reduction part. Yes, this is the handle of infinite values and all. So yes, I have did it successfully. So the next part is the scaling of data. I have using here the standard scaler. Why I am using standard scaler? I am just give you a single snapshot, and it is the visualization after standardization. So you can see this figure. Multiple figures are there, distribution figures are there, and if anyone know about the distribution pattern, this distribution is not a linear distribution. This distribution either some left sclerotic or right sclerotic or moderated distribution, like that things are happens over there. So this is not a linear options are there, but here most of the part you can see are the outlier values are present there. So whenever in your data you have the outlier values, or you supposed to have, yes, I have some outlier values or the values having high ranges. So in that case, you have to use the standard scaler technique rather using the min max scaler. So the next part is that the feature reshaping, how you have to reshape the feature, because you have to dealing with the from 3D component to a 1D component. It is also a expertise kind of thing. So at the last of the end, we have the, I think, 35,937 datas, column data, row datas with 4 and 44 features. So the next part is the train and test split. We have using 80-20 rule to split our data, and this is the test data I have created up to there. So this is the first part, module 0, data upload and preparation. So let's moving on to the next part. That is the computational strategy matrix, multi-paradigm approach. So here we have used 4 modules. The first module is the DenseNet LSTM. Second one is the CART-NNN hybrid, SDACA and VCGA. So every one of the module have their different applications and identities. So the first thing is that the module 1, the tracking the spatiotemporal land degradation via DenseNet LSTM. So we have used 2 LSTM layer, 1 DenseNet layer, and the final output will be in a dense layer. And the Bayesian network also used, Bayesian optimization by Keras-Tuner is also used as a optimization function. Let's do it in our Colab. So here is the module 1, building DenseNet LSTM. So as earlier I said, we will use the Keras-Tuner, TensorFlow, scikit-learn to build that whole model part. So this is the modeling pipeline. So in that modeling pipeline, there is a different sections is there. There's the first LSTM layer, how you are able to tune this first LSTM layer, the minimum value, what is the maximum value, what is the step. In our first and second webinar, we have discussed this in a detailed manner. And in the upcoming course, we will also dealing with that part in also a very detailed way. Turn activation function, there is a different activation function we also use, like that thing. And this is a very important thing, that is the define the tuner using Bayesian optimization. So optimization function we have also used here, like we have used the 5 trial and execution part trial, means we will use our whole model, run each a time for 5 times. So after trial 5, we have got our best units for LSTM1, LSTM2, for DenseNet layer, and the learning rate also we will gain. Next part is that to train our model. This is the training of our model. And you can see also the losses, the amount of losses. It actually minimizes throughout the approaches. We have used just 10 approaches to show you. You can use 100 of approaches. Next thing is that the prediction of the test data. We have predicted the test data after confirming the loss values. Next, evaluate the model. So we get the mean square error 0.008, mean absolute error 0.177, and R square as 0.60. Yes, it is bit small, R square. It might be increased. If you want to increase it, you just tune this part. You have to tune the Bayesian optimization, and you will get it at its maximum portion. So the next part is that make prediction on the entire data set. You have to predict it in form of the entire data set. Now, this is the time for plotting. So this is the training and validation loss. You can see in the first, in the 0 to 4 approaches, the line are actually coinciding. But after that, it actually makes a sense. The train and validation loss is actually diverted in the opposite direction. So it is a good sign of any model training part. Next, it is the weights, how each and every layer have received the weights. It is some of the diagram of weights, how the weights have been transferred over there. And this is the kernel weights. So the difference between each and every layer's weight and also the kernel bias and recurrent kernel weights are bit different, and we have also discussed this in our first and second webinar, which is actually a paid webinar. But don't be upset. We will discuss this step by step in our upcoming course if you want to join it. And I request you all to please join this course because it will be a big fun, and we will learn it in detail. So the next part is that we have to save our model in 3 parts. That is for .keras, H5, HDF5 format. This part is very important for you because when you are working in the Google Colab, most of the time it is crashed actually. 1 minute. Okay, so here is the TensorBoard visualization we have created over there. This is a dashboard type of visualization. You can easily create it by using your data sets and all. Like the train and validation curves are there, how each step, how the training and validation are actually happens in your model. So this is some of the things you can easily build over there. This is also a TensorBoard. So this is SHAP file. This is the visualization of SHAP we have been created. This is AUC ROC curve, and it's the confusion matrix. Case plot. This is the case plot. This is asymptotic one sample case plot. So it actually shows the EDFC, that is empirical distribution, and the calculated distribution, how it is different from it. So you can see it is there is a genuine gap, but not that much of gap remains there. So you can get the case statistics from there, the p values, and it is how it is significantly shows your things. This is a precision recall curve. So this is all for the, I think, the module 1. Let's move on to our module 2, that is the morphology classification, how the settlement morphology change have been detected within the CART-NN hybrid framework. So okay, sorry to interrupt. So the module 2 is that the morphological classification CART-NN hybrid formulation. That is, the first stage is that the probabilistic extraction of CART, that is classification and regression tree. It actually builds a fusion of trees. Next stage is that the fusion block, how it infuse the original data, leaf indices, and the probabilities. And the third stage is the how the deep sequential processing have been done by using the NN hybrid format. So what is the SMZ, settlement morphological zone? Settlement morphological zone is actually represents a morphological unit either having different types of vegetation condition or its building conditions. Like if I will show you how the SMZs have been incorporated. So this is the module to execution, concatenate and sequential modeling, how each of the blocks have been developed, extractor block, fusion block, and the neural network block. Let's move on to the Google Colab to done our module 2. So this is our module 2, building a card module. So this is our defined features are there. We will be focusing on the Gini and entropy based calculation by using the card classification and regression tree. So this is called as a forest, decision forest. We will call as a decision forest. From here, we have to take 1:4 ratio or 1:5 ratio to detect the decision or to make a decision of any of the sites or any of the conditions over there. And this is the impurity table. This is the Gini impurity table is there, and the entropy impurity table is there. You can see water use efficiency performance having the highest is in the top of the table and having the highest node of the probability. What actually it means? It means water use efficiency is actually calculated by using the productivity of a land and its ratio to the evaporation, the evapotranspiration demand. What it actually means that if your region having list of trees or list of canopy crowns or canopy, it will automatically lower the evaporative demand and actually loses the performance of that area. So as this area is a master plan region, so the growth of that part of the growth of that region or the built-up expansion is actually diminishing the forested or the canopy layers. That's why the water use efficiency performance have been degraded over there. This is the view of the canopy tree. The decision tree, 1:4 ratios. The first one is the Gini and the second one is the entropy. You can see the water use efficiency is the first priority decision making thing, that water use efficiency is diminishing. Next the biomass, and next the fragmentation. It is actually give you a sign that this region is actually in the favor of rapid built-up expansion. This is the settlement morphology zone wise. So settlement morphology, I have identified this type of settlement morphological zones, like the open spaces, low vegetation, open spaces, medium vegetation, like that. Moderate residential places, high residential places, very low residential places. So when the evolution of any urban system happens, so it not only happens by converting a land use land co. It actually happens over a area unit of problem where different kinds of things are assemblage of things are there. Like suppose you have a 10 by 10 unit area over there. So what land use land cover change actually happens there? Suppose this 10 by 10 area is actually a full of vegetation cover area, but in the 2000 the condition is there, but in 2010 most of the area is converted towards the building part. Suppose the whole part is the 100%, and in 2010 it is actually converted towards 10% of built-up area. So what type of built-up area is that? So either the built-up area is the residential built-up or it's not residential built-up. So that type of questions is actually makes sense in the settlement morphological zone based analysis. So you can get each and every settlement morphological zones diagrams and maps. So you can see this is the table of each and every settlement morphological zones. This is the diagram of that impurity node, how the impurities are actually traveled throughout the nodes. Okay, I'm directly moving towards that part. This is the dashboard part. So you can see here I have calculated different types of correlation matrices are there, feature correlation matrix are there, how the model is evolved, how the trees are actually built in each and every section. You can easily visualize it by using your own set of dashboards. You can easily create it in the Keras tuner. It is the biases. This is the smooth curve, how each and every steps the loss function have been evolved, or the loss is actually minimized. These are the different types of graphs. Let me show you a table. I think the table is over there. That is the table. So you have the settlement morphological zone, each of the settlement morphological zones, and you have the top features of Guineas. So all of the settlement morphological zone, not like the moderate non-residential places, and the high non-residential places, remaining all of the settlement morphological zone, you will see the water use efficiency performance is actually the top Guinea feature for the degradation part. So it actually signifies how the vegetation cover have been lost over that area, or tree crown surface have been degraded over that part, which actually culminated the land degradation. Let's move on our third module, that is the stochastic urban simulation. So we have used the stochastic differential equation and cellular automata over there. The stochastic differential equation is actually preparing an equation based on its development or its own set of criteria. Like here we have used two different types of things. One is the drift and diffusion. So the drift thing is that the growing vector mapping to show how the urbanization pressure is actually culminating, and the next part is that the noise intensity present is the stochastic human settlement data. And next is the cellular automation function is also have been used. I am directly moving towards the module where you can see how we can build or we can simulate that part also. So this map is actually shown the present land cover situation over there, and you can see the red one is the building and the yellow one is the croplands, and there are some green areas are there. So these green areas are actually the canopy zones are there. And if you directly move towards the red portion, you can see the protection spaces actually calculated from the land productivity trajectory degradation. So the yellow part is actually show that it is in an improvement stage. So what we will do in our simulation, we have to protect this zone from this conversion or this land conversion or this built up expansion. So this is our target. Let's move on to our R portal. So this is the first thing, we call the first thing is that BAU, that is the business as usual case, where we have integrated all of the land use land cover data and the land degradation data. And our main first focus in the simulation part is that how the land degradation is accelerating in the if the current situation or current rate of built up expansion is happen over the region. So this is actually the building block. I am not going into the details, but I am showing you some simulation parts of thing. So you can see the simulation. I think simulation will occur over there. So you can see this is the simulation. over there. So it is the step 1 to step 20, how the area is actually evolving, or the simulated LDE, land degradation exposure, is actually developing over that part if the current rate of building footprint is maintained. This is our snap view. Of that thing. You can easily see the different steps are there. For the first step, it is the land degradation portions are there, and how it is accelerating in the further steps. Let's move on to the next part. Let's visualize the neighborhood. So it is the neighborhood dynamics, how the cell values, the original cell values and the simulated cell values are actually show the similar pattern or the fitting pattern over this simulation. So this is the cell and neighborhood code. This is the neighborhood average, cell neighborhood average, and the cell neighborhood average for simulated and the original one. If I able to zoom it, you can easily see this degraded part, the first original or in the original state, the first degraded part don't having that much of aggression over that part. But when we integrate the simulation part, this sector is actually elevated, or is actually making expansion scenarios, or the expand or trying to expand over this region, our protected region, which area we want to protect. Let's making the cluster to show which zone we have now to deal with in the plan. Okay. So this is the Getty's ODG hotspot over the settlement boundary. So you can easily see the hotspot regions over this. The red signals are there. So this region, we have to make plan over that region to how to sensitize this ecological degradation over that part. So let's move on to the next part. I am also calculating the have also calculated the Moran eyes in that part. You can see the Moran eye figure also here. It will take some times. Session I can expect. Yeah. So that's part. So the next module, our next module is that the scenario modeling. We have incorporated the plot per green space integration. So how we will integrate that part? I'll show you. So this code, I am just running this whole code. So this is our policy scenario. If we are trying to integrate plot per green space 15% plot per green space over that region, over that sensitive region, what will be the land degradation scenario. So it actually reduces. So this is my intention to show you how you can actually integrate the policy scenario over that part, over your simulation, by incorporating not only the main data but also your probabilistic framework also. So you can see in the step 2, this is the main land degradation corridor is there, and in the next few steps, up to the 20 steps, it is actually reduces. So this we can incorporate in our planning part. Let's move on to our next pipeline, that is the module 4. I will not show this part in hands-on mode. I will just discuss this part because it is I think 8:28 now. So we just have 10 minutes to discuss, or 5 minutes to discuss this part. So the automated 3D, how you can create the VCJ, virtual computer graphic mass modeling pipeline. So you can use the city engine part to do that. You have to do the geometry mapping, rasterization, and shader processing. It is the basic thing. What you will do in the stage 1, that is the geometry mapping. The feature vectors are explicitly translated to physical spatial forms to develop the outlines of that part. VCJ pipeline 2, that is the rasterization, how the features are actually converted to the raster part. Next, the VCJ pipeline stage 3, that is the shadering processing, that is the nonlinear enhancement, how you can enhance the nonlinear process. And after doing that shadering process, you actually build the mass model. This is the digital, we actually called it as a digital twin. This is actually the mass model transitions. So this is the automation of the digital twin architecture. You can easily create this type of graphics by using the VCGA over that part. So this is the digital twin translation scenario modeling results. So you can create plot per 15% green space and the 75% building at that part to simulate your results in that funnel, how you can actually reduce the land degradation over that degradation space. So closing, I'm wrapping up over here. So what or how this framework will help to actually resettle the action plan. So for the title holders and the non-title holders, for the title holder and non-title holder, VCGA mass modeling precisely calculate physical replacement capacities, optimizing housing assistance and structuring compensation footprints. For vulnerable groups, optimal placements in the digital twin ensure equitable access to generate residential green space and preserved community corridors. For ecological fragmentation, the avoid reduce reverse hierarchy module mitigates EDFC phase 2 fragmentation, minimizes the vegetation loss and hydrological disruption along the 40-60 meter row. So we can actually reduces the ecological vulnerability and also the resettlement action plan through this comprehensive framework. I know this is actually a conceptual overload or the mechanical overload over you guys, because I am giving it a very rough overview over that part, but my intention towards you is to convey what we can actually do in the planning part or in the urban planning part, which actually misses in the most of the researchers and most of the sectors. So thank you all for patientful listening, and I am requesting Shayantan to please join and carry on the further process. Thank you.
Okay. Hi, everyone. So welcome back. So Nilanjan. Okay. So that's a great lecture. It's a lot of technical things, technical stuffs are there. So I don't think any of the webinars before in the urban has shown this much level of technical expertise at a free webinar. So that's a great thing from Nilanjan's side. And Nilanjan, are you listening to me? Nilanjan?
Yes, yes.
Yes?
I'm sharing. I'm
Okay.
sharing.
Okay. So just as I told you that we will be now fusing some of the beautiful things. So can you please open the slide that we have mentioned earlier regarding our not this one. I was talking about that our slides on this particular how we are actually using this urban planning with this that part. So this is the first slide, or can you go to the second slide? Let me see that if it is in a clear order or not. Okay, so please come to the first slide. Okay, so come to the first slide. Okay, so that's great. So the one more thing that we just want to tell you that as we are from the different domains, but we are actually doing what? So learning AI is not our main goal. Our main goal is to ship a final product, to get the more insights, and to find out whether our knowledge in artificial intelligence is actually solving the problems or not. If it is solving the problem, then it is good. If it is not, then there is some problem in it. So for that, we were just working that my expertise is on the geo hazards and natural hazards. And I was talking with Nilanjan that how we can use these urban platforms or the urban planning platforms and knowledge and insights from Nilanjan and how we can act that with these particular natural hazards. So the thing is that you can understand that if you are from a region that actually faces a lot of flooding, so we can amalgamate that the flood inundation modeling or flash flood susceptibility modeling or any simulation modeling of the flood with this urban infrastructure that we have tried to do. In one of our papers that we are actually working on a real projects on the Himachal Pradesh in Mandi district, we are actually showcase that. So please Nilanjan, can you go to the next slide and we can show you that how this inundation extraction helps in amalgamating with these particular natural hazards. So you can see that in this satellite image, this is a HECRAS simulation. So basically it's an hydrodynamic simulation. Why it's an hydrodynamic? It has the rainfall as well as it has the all the base flows and everything. For example, it has the ungauged basin, gauged basin, river dishes, everything is there. So basically what we are actually showcasing. So please can you run the simulation once again, Nilanjan? I think it has gone somewhere. So can you please run the simulation? So you can see from the simulations that this particular water is going over a few of the buildings. So what are these buildings? If we have made a proper urban planning, then what happened? This Thunag village would not have been destroyed. This particular village has been destroyed in 2025 in the time of 30th June to 1st July during the midnight. So what is happening is that as a GIF and it is going constantly out. So I just want to tell you one more thing that this particular simulation says that how we can use the velocity, we can use the water depth, and we can use the water extent, and we can amalgamate over the urban infrastructures or any other urban planning infrastructure to see whether the flood is actually rising above what height. So if we can make a zonation so that the river does not get encroached and the buildings become safe, then we can actually have a final output. So building a simulation separately rather than amalgamating it over a particular urban areas or particular built-up areas, it is not providing our real solution. So Nilanjan, please go to the next slide. I just want to show you how. So you can see that we have already demarcated the number of buildings. So these buildings have been demarcated using segment anything model. That is because digitizing each and every building is very tiresome. So we have use a vision learning model, that is a segment anything model, to identify each and every buildings. So you can see that we now each and every building is overlapped with the flood water extent that when it has occurred, you can see lots of buildings are under the water. And so from here, it's a very simple way we can show that how the concept of this urban planning through vision learning models can actually help us to understand the simulation of the water. For example, you can see that the buildings which are flooded, okay, so there are these buildings are actually flooded. So it was not there before. If we have only run this particular simulation, after running this simulation, we draped the building over it. So in this way, what we are getting, then how many buildings are really vulnerable or not. So we are actually bridging the gap between urban planning and the natural hazards. So in this way, nowadays, there is a very good terminology has came arrived, because in the last 1 or 2 year or 3 year before also, whatever the disaster studies or whatever the research has been going on in the industry as well as in the academics, you will find they are either related to only one particular aspect. Either it is urban planning, and in terms of the disaster or a hazard disaster, it is either seismic wave like earthquakes, it is either landslides or flash floods or cloudbursts like this. But now the situations are complex. We have to amalgamate all together, and we call it a cascading effect. So this cascading effect leads to this multi-hazard. So we have to understand that why multi-hazard is important and how this cascading research can actually help us to understand that we can come from an HECRAS simulation model, from an IMD based graded data rainfall to a building level accuracy, that which buildings are actually vulnerable and which buildings are not. So these are some brilliant things that we can actually build out of it. Nilanjan, can you please go to the next slide? Okay. So in this next slide, you can see that this particular model that we have built in the previous slide that we have shown, it has more than 95% of accuracy. We have actually measured, and our team, one of the team has visited this particular place in the ground for the ground truth, and after ground investigation, we found that 95% of these particular buildings have been demarcated well using simulation. Because if data is correct, then the simulations will be correct. And when simulations are correct, if you are intelligent enough, you drape it over this urban infrastructure, and you will see that how these particular buildings are made. Okay, so I told you that two of the most interesting facts that we will be showing you how. But before going to show that, can you please go to the next slide, Nilanjan? I just want to showcase one more thing, that why now the question is that why this type of, because rivers have been there for last 5 to 10 years. And there are a lot of floods, but why does in recent year that buildings vulnerability has been increased, or why there is a high vulnerable buildings nowadays? Is it only because of the climate change, or is it only because of the erratic rainfall, like extreme rainfalls in few short period of time, or increase in flash flood? Yes, that is one point. But another most important point is the river encroachment. The buildings are making in the side of the rivers, for like the hotels have been made side of the rivers, the cafes and restaurants are made inside of the viewer, in the side of the river, for the name of aestheticism, because we all want to visit the aesthetic places. These are Instagram worthy and Pinterest worthy places, because these particular places gives very beautiful pictures. But because of this, the rivers are getting encroached. So when the river encroachment occurs, and if there is a sudden flash flood occurs, there is no buffer mechanism. So for that particular reason, that the entire settlement get wipes out. So these are some of the pros and cons that we can see, that in terms of nature, we have to respect the nature, we have to understand the nature. Everything is not social media worthy, everything is not a Pinterest worthy thing. So we have to understand that growth and development should go side by side, but here we actually look for the growth and no development is there. So you can see that this particular building, this was actually a hotel which was very near this particular river, and you can see that this particular hotel's base has been wiped out. Why? Because it has been made very beside of the river, so that it can attract a lot of tourists with a riverside views, good sunset, good sun raises and everything. So now see, the entire building's base has been wiped out, and this building becomes no longer fit for any type of stays. So these are some of the important things that you need to keep in mind, that apart from machine learning and artificial intelligence, visiting the ground and see the reality, and then coordinate that whatever results we are getting is actually correlating with our study or not. So this is one more thing. And please come to the next slide. I just want to talk few more things about this. So to the one of the fascinating courses that we will be talking about, that we will be teaching you. So you can understand that for the last 3 to 4, we have done last 3 to 4 webinars, and we have got some very good reviews from our students. Basically what is happening, that we have done 2 of the paid webinars, and we got very good reviews from you people. So you can see this is a consensus dashboard from you people that you have actually made, all the students and participants have made. So we have got a very good rating from you people, and we are really glad. And so for that particular reason, you can see that there are a lot of students has actually commented us that what they have learned, because we have teached everything from scratch. Because today what Nilanjan has shown you, you might got a fear that okay, we can't do that, but everyone can do this type of things, because you have to learn this. So we are launching this course so that you can actually learn how these basics of remote sensing can be done. So you can see that all these people have given us such a beautiful comment. So So when coming directly to the course, I just want to tell you it's a very basic course where we'll be teaching you all the machine learning. And you were asking about what is the blueprints of this course, but we are giving you an entire depth that how this particular course can be taught and how these particular ways you people can actually learn what we are teaching. So coming to the course, please Nilanjan, go to the next slide, and in the GUI mastery program, and you can see that we are doing something great. We are not only showing you Pythons, we will help you to build every models from the scratch, how to make a data, because in a data science or a geospatial data science part, I just want to tell you that it is not the coding part, it is how you visualize the data, because majority of the portion of this particular course will be dealing with how we will create the data and how this data will be stacked or transferred into a machine learning model through the Python libraries. We have to understand the numpys and arrays for that. So for a practitioner skill pathway, that for industry what it requires and for the academics what it's required is that we have to create a foundation. Then we will show you analytics. Today we are here, Nilanjan has shown you an MLDL mastery. Next we will tell you about what is the MLOps, that is end-to-end ML operation pipeline. So how we can build this ML operation pipeline, because building one ML model is very easy, but building an entire pipeline so that it can ship and deploy and it gives a continuous results is very important. So that is the more important thing. So for this, we have divided our course into two parts. One is the curriculum part 1 and part 2 and 3. In part 1, we is the most important part where we will be teaching you how to actually generate the data, how to create the data, what are the different sources from you collect the data, and how you actually convert the data, preserve the data in such a way that it can actually help you to get it into the Python and do the ML part of the machine learning part. So when you're coming to the spatial predictions problem, we will be teaching you what are the events and non-events. These are the two most important things that majority of the people actually don't understand. And we will be actually telling you how this event or non-event points are actually made. This is the trade secrets of our particular course. So when you get to join this course, when you will be joining this course, we will teach you this secret blueprint that how to train these with logic, with grammar, with data science, with statistics, as well as probability. You don't need to be a huge mathematician to learn this. We will teach you everything from the scratch in this particular course. Okay. So then after coming to part 1, we have divided this course into part 1, part 2, and part 3. So part 2 and part 3 are together, where we will be doing all the Python stuff. We will be typing each and every code by our own hand and showcase you why we are typing, how we are typing, and what is the need of these, what is the visualization, how you can deploy or how you can create a code out of it. So you don't need to be a coder now, but you need to learn each and every line of the code so that you can understand that if any model fails to deploy, then how will you rectify it. Okay, so this is not a vibe coding code. This is an entire code that I will teach you from the beginning to the end, because if any of you have joined our paid webinar, then you have seen that how we have actually built this entire model from the scratch, especially in the paid webinar 2. We have typed each and every, we took 2 days to code one, but thing is that we want to teach you everything from the beginning to end, so it's a long course. Okay, so we will be teaching you accuracy assessment, we will be teaching you something that will give you a publication grade of knowledge, and number 2, we will also show you how to upload this code in a GitHub and how to maintain your GitHub account so that you can get some industry supplemented. Is that yes, when you're going to give an interview in an industry, you will tell that I have this GitHub. And today also I will show you that one of our product, that how we have built one product in our industry and how we are actually deployed with a proper web dashboard. We will be showing you. So these are some of the papers that are actually there that we have published in the last 2 to 3 years, that how we have used artificial intelligence, machine learning, and published this paper, and how industries are nowadays using this type of works and our expertise. So coming to the next slide, so we can actually show you that what is the pricing. So this is a very less pricing, that is an early bird pricing rate, that for the students, if you want to take the full course together, it is only 4,999. And one more thing, if you come in a group like 2 to 3 people, I can tell you, I can guarantee you that see, you can see the prices here. That if you 2 to 4 friends come, we will reduce the prices. You will just comment us, just give a text to us, DM any of us, and we will make you this entire payment system. Okay, so it is a very less price. And one more thing, if you still have these trust issues that, okay, so we don't want to pay huge amount of money, but we want to learn step by step, and we have a very beautiful course that we have divided this course into 2 parts, the part 1, part 2, and part 3. So part 1 course is value is this, that is 1499 only. You can join this part 1, this value, you can learn entire thing in the part 1, and if you like, then you can go to part 2 and you can pay the rest of the money. But this money is not actually in a offer mode, so you have to pay this entire money to in separate way. So this is one more thing. So if you face any problem, you want to join our program, that's a great thing. You will learn a lot of things, because many of the people think that, okay, we will not giving 4999, 4599. But thing is that if you go to a shop, you go to a shopping, you buy one good shoe, it will cost 2,000 to 4,000 rupees only. So that is the thing, in 2,000 to 4,000, if you learn something that can build your career, because this is the future. Because if today you don't learn machine learning, artificial intelligence, tomorrow you can't even survive in any of the industries. Okay, so these are the few things that I just want to tell. And now I will be showing you some of the good things that how we ship our products actually. So let me share my screen and I will show you how we can ship a product here. So let's see. Okay. So I am sharing this entire screen, and let's see. Okay, so here we are going to suppose this is a GitHub. So let me show you from the beginning. Okay, GitHub. Okay, let's go to the GitHub. So in this GitHub, okay, so this is the GitHub page. So if you register in a GitHub, then okay, I'm just removing this one. If you I think my screen is visible. Okay, is it visible? Please, you can tell, anyone can tell if it is visible
Yes,
or
sir,
not.
it's visible.
Yes. Very good. So suppose we have actually built one rainfall dashboard system, that how we can actually collect the rainfall from the IMD data, because IMD don't provide district-wise data in a repository format. Okay, so acha, one more thing, that my video has been on from this another particular. Can you see my video? Okay, let's actually click on here and see. Okay, so now my video is visible. Okay, so we have made a rainfall pipeline. Let's search it. Okay, in GitHub rainfall pipeline. Okay, so let's search it. Okay, so let me see it is what it is telling, 0 results. Okay, let me see in this way. Let's search it here. So you can see there are a lot of rainfall pipelines are here. Someone has made rainfall predictions and everything. So I have made it recently. So let's go and see. Just clicked on recently updated. You can see that's my name is there, and I'm clicking on it. So this is the rainfall pipeline basically that I have made, and these are the current deployments that have been gone. So I'm clicking on this, and I will show you how I have used the GeoAI to build one entire web dashboard that collects the rainfall data from the IMD automatically. I don't have to go to this every day to upload the data. It will do it automatically. I don't need a proper internet connections or anything. If I go offline, if my laptop gets stored, my mobile gets stored, I don't need anything. If you go to this site each and every day, every day you will find that the data have been loaded. I built this on the 13th, and till 17th it is collecting data every day. Sometimes it takes a delay to collect the data, but it is actually collecting data every day. So you can ask me that what type of data it is collecting. Suppose you can go to any state and district. For example, you can see in India, one of the highest rainfall has occurred within few days is in the Magnan. So this is a Sikkim, it is a district in the Sikkim. So if you please select the state of Sikkim. Okay, so let's go to Sikkim. Okay, this Sikkim, and go to the district in Magnan. You will find what you can see. There's a huge rainfall on the 15th, and then it has decreased. So this is the web dashboard that we have built actually using the GeoAI techniques that will collect the data from the particular IMD websites, because IMD does not keep this data repository. They only provide the grid data, but does not give the district-wide data every day. You will only get this data on the current day, and no other day you will never get the data. If you go and search it also in the internet, how I can get the district-wide data of IMD on the day of 14th or 15th, you will never find. But if you come to this particular place, you can actually get all the data you actually want. And if you want to download the data, you can also download this data from here also. I will show you from where you can download this data. I have made everything available for everyone. You can go click on this data, and here you can click this raw data, and here you can see the CSV file. Click on any of the CSV file, for example 14 CSV file, and you will see that the date is 14, it is a period, and you can see subdivisions, state, districts, and all the rainfall and everything you will find here. Okay, so this is something you can see that I have made this available for everyone. These are some of the beautiful products that we actually built through our machine learning model. So these are something that we are building today, and we are deploying it. So this is an end-to-end entire pipeline. So you can understand that how this entire things are actually made. So these are some of the things that I just want to tell you. That before ending also, I just want to tell you that there are a lot more things I will show you. One more thing, let RevoMap Solutions tell about this course curriculum, and then one last big bang thing I will be showing you. So it is in my laptop. I will go to my laptop and will show you that how I have made and I am developing another AI model that will actually do the entire LULC part, and you don't need to actually create a model. So that is in a model development stage, and I will show you there, but we have to wait till the end. And before that, let RevoMap Solutions provide you all the information regarding the courses, what is the dates, and from when we will start and how we will start. So RevoMap, I want you to actually go through this, and so that the student can actually understand that how this, on which day the course is starting, and how this entire course will be doing. So thank you, my friend. And RevoMap, please take the dice and let's begin.
Yeah. Thank you, Shantan. Am I audible?
Yes, yes.
Yes, you are audible.
So first of all, thank you to the members from Darshini Group. They have presented an excellent webinar. And now, as we promised that we will reveal the course structure today, I'll just share my screen, and please let me know whether it's visible or not. Is it visible? Yeah, okay. So this is the
Yes, sir.
course structure that you can see. I think my entire screen is visible right now. And this is how we have planned this. First of all, let me be very clear. Unlike other courses, other professional courses, we are providing for the first time something called the credit-based course. As you can see, our course is actually divided into 24 hours theory and 48 hours practical or hands-on training. Now, this is in parallel to the regulations provided by the AICTE and the UGC, and thus we are able to give the institutional credits that are specific to our institution that we have collaborated with Darshini Group of Solutions. And we have divided this course into two parts of theory and practical, with 1.5 credits in theory and 1.5 credits in practical. Now, after completing this course, when we provide the certificates, if you actually issue the certificate somewhere to any employers or any universities before admission, then you can actually state that, yes, we have completed a course that is based on the credit system of the university guidelines. Now, secondly, how we have planned this course is we have divided this course into two parts, coming into part 1 and part 2. As you can see that the course begins on 26th of April, that is next Sunday, and it is actually happening on the weekends, that is both on Saturday and Sunday, and the timing is from 7 p.m. to 9 p.m. Now, this has been done keeping in mind of the work schedule of all the students, of all the working professionals and the scholars, and thus we have chosen the weekends to actually deliver this course. Now, it is divided into two parts. The first part is beginning on April 26th, and it will likely be ending on the second week of June. Now, once we are ending the first part, we will give a 3-week layoff. And within those 3-week layoff, you can specifically see we have a skill consolidation program, wherein we will give you assignments over the last 1.5 months. What we have taught you, we will give you as assignments, and you are required to submit those assignments. Followed by that, we again begin after the 3-week layoff on July 1st or 2nd week, and then we will continue this course up to mid-August. And in this entire portfolio, we are going to cover the entire 72 hours of the work. Now, the thing is, in order to receive the certificates, the attendance of the students are mandatory. If at any point of time any student is facing any problem, there would be recorded videos, but we would request them to at least cover 70% of the classes. Followed by that, the regular assignments that we will provide must be completed. And finally, the most important, that there will be a capstone project at the end of the session or end of the course, that is in mid-August, and that capstone project needs to be completed by each and every student for receiving the certificates. Again, I shall mention that we are an organization who are ISO registered, who are EUDM registered, and we have our legal registration. Thus, this certificate is entirely valid and entirely important. Now, if you complete all these parameters, if you are successful in completing all the projects, yes, you are going to get a certificate that is worth of doing and completing. So that's it from my end. And I would again request Darshini Group of Solutions to come and
Hi.
show us the hands-on training.
Hi, everyone. Am I audible? Am I audible?
Yes.
Yes. Okay. So the thing is that we are actually building, because a lot of people actually nowadays use LULCs and this future classification mapping. So for that particular sessions, what we have built is that, let me share my screen actually. Okay. So let me share my screen and let's see that how it actually goes. So we are actually building an AI agent system entirely that will actually help each and everyone to learn a lot more things. Okay, I'm just stopping this one. Okay, and let's see. Okay, so here, so this is my entire Google Earth Engine based LULC automations that basically directly download the data from the Google Earth Engine, and I'm actually building an entire web dashboard out of it. You can see it's a local host model. So this is an LULC change detection system that we are actually building here. So what it is happening is that we are only using now Sentinel data, and if we go back, then we will have to again add another data, that is of the Landsat data. We can provide the shapefile path, we will start the date, and we will change the cloud.
Anton sir, I am just interrupting you. I think the screen has become entirely black with only the name showing LULC change detection.
Yes. It is only this is in the, you can see the site parameters.
Okay. I understand.
Okay. So we have not added anything till now. It has just a link with it, and we can just show you that how this we are actually building. It takes time to build actually. We can't build everything every day. So here we have also added the cloud cover changes so that for the LULC we will take less than 10% cloud cover, and then we will be doing some model training, and then we will, like, model training does not occur, we have also kept an options of an manual training. So we are actually building this type of system so that the entire automations can be made. So we are not only working only as an academicians who are there to only publish paper, but we are building to solve some real problems that are going on the ground. So we are making an entire LULC change detection system where you don't always need of this particular training. You don't have to train the model. We will be using pre-trained model for this type of classifications, and we will compare the results. So in this way, with a very short period of time, you can do a lot of LULCs of different time frame, and you can actually predict the land use, land cover changes for the future using cellular automata that today Nilanjan has told, or any other model if you develop that is much better than cellular automata. So in this way, we are also building. So these are some of the products. I just want to show you that I don't know how many webinars actually showcase you this type of models, that 2 to 3 models that we have actually built. But here it is this, that I always tell you that we will always deliver you something that no other people has actually delivered. So I think that's from my side, and I have stopped sharing my screen, and these are some of the models that we are actually building, and hope that in very soon we will build this model entirely of our own, and then we can actually use lot of LULC out of it. Okay, so that's from my side, that what simulations we are doing, how we are building model, what models they have already shipped in the GitHub. So all these things are important nowadays if you want to stay in the game of Geo AI, artificial intelligence, because this is the future. Otherwise, there is no future. You can't sustain in this world without learning the AI now. So that's all from my side. And now I just want to tell you and encourage you all that if you join the course, learn all the basic things, then one day you will also be able to think like me or our team, so that we can actually work together, collaborate with each other, and build something at an enterprise level that can be actually delivered to a highest level of industries. So these are some of the things, because Geo AI is a very beginning in this world, because with the advent of AI, geospatial science has been developed it's growing in a farther way. So the thing is that if today we don't learn this Geo AI, then tomorrow we will miss a lot of things. Okay, the person at 2013-14 we missed the bitcoins and everything, and today if we miss the AI, then there is a big problem. So that's from my side, and thank you all of you for giving so much of time to our particular webinar to understand what we are trying to teach, what we're trying to tell. So I hope you people will love the course, and I want all of you to join the course, learn from us. At least if you don't want to join the full course, at least join the part 1 at least, and see that what we are teaching, how we are teaching, and how these things are different from rest of the webinars that people are already there. So we are the startups, so we will teach you everything. We will under promise and we will over deliver you. So we are not the people who over promise and under delivers. We are the people, those who under promise and we deliver more. Today we told that we will be showing you 1 or 2 hands-on, but you can see Nilanjan has shown so much of hands-on. We are showing so much of simulations. We are showing our final products. We are showing our secret products also, so that you can actually have some understanding them, what to build, how to build, where to build, and when to build. So that's all from my side. Now I am again giving this dice to RevoMap Solutions, so that they can actually facilitate the special lecturers, those who have actually given you insights.
So thank you once again, sir. And there is one more special announcement to all the participants who are here today, who have sacrificed their weekends, that those who have missed the sessions of the webinars of the previous 2 webinars, that is webinar 2 and 3, those who have paid webinars, you can actually contact us. And yes, we can arrange it for a discounted price, and you'll actually get the insights of those 2 webinars. So that is a special discount for you. And followed by that, as I just quote, the course begins on 20th of April. You are free to ping us, come to us, discuss with us, and we will find out a price for everything. Secondly, there will be recorded sessions for each and every session that we are conducting, each and every session. At any point, if you miss one session, you come to us and we'll provide that. It will be given in the drive. Thirdly, you are getting one-on-one mentorship. At any point of time, if you are facing any problem at any code, yes, there are technical persons who will actually attend you one-on-one. So that are the basic benefits of the course that we are going to conduct from the next week. So that is it from our end. We thank you all once again for joining this webinar on this weekend. And now we hope to see you on the next weekend too in the main course. That's it from our end, and curtains down from RevoMap and Darshini Group of Solutions. Thank you and good night.